Hello everyone, I am Anshika Singh and welcome to the series where we build intuition around different mathematical topics in under 10 minutes. And today's topic is division of a polynomial by a polynomial. We'll begin with understanding what polynomials are used for, and then we'll further proceed by modeling a scenario. Using this simple scenario, we are going to understand the three major concepts of the entire topic of polynomial division. These are remainder theorem, factor theorem, and division algorithm, long division method. So let us begin. As a human being, we might want to mimic some natural phenomena, for example in virtual world building, or we might want to predict some natural phenomena like rain, wind, or we might want to predict some natural disaster or things like that. In order to accomplish that, we need advanced mathematical computing capabilities. Okay, in simple words, we use mathematical equations in order to explain few of the or some parts of some natural phenomena. Okay, movement or nature of a surface. You understand it, right? At the very fundamental level, you can understand, you can think it like we want to, or we use polynomials for mathematical modeling of real world scenarios. Now, in order to understand it at the basic level, we will model a very simple scenario. Let us assume that your father has called and informed your mother that he'll be bringing some guests home for an evening get together. Okay, now he requests her to prepare some mango juice to be served. Your mom prepares it in a container of some volume. Okay, just assume that container is of some cubical kind of, approximately its shape can be approximated as a cube. Okay, each tumbler in which the drink has to be served also had some volume. Your father usually brings back 2 less guests than he mentioned, so your mother prepares 2 less glasses in advance. So this is a real world situation. We want to model this. So let us assume that there is some relation between the number of guests and the volume of the container, so we can express them using the same variable. Okay, so now let's proceed with forming mathematical equations. Let's assume that father mentioned x number of guests, so the total number of glasses prepared is x minus 2. Let the shape of the jug be such that it can be approximated as a cube of side x units and stores 8 cubic units of liquid less than x cube units. Okay, thus the total volume prepared will be x cube minus 8 cubic units, right? You might want to find out how much juice will each of the guests receive and how much will be left unused. Okay, so in this case, what you will do, you'll simply divide the total volume by the number of guests, right? If you look at the entire situation, it is nothing but simple case of division. But since we do not exactly know the number of guests, we have assumed it as an x, which is a variable. So we are dealing with a division of a polynomial by a polynomial case. Hence our required answer will be x cube minus 8 divided by x minus 2. When we divide a number by a number, we can simply express it as dividend is equal to division into quotient plus remainder. Same is true for polynomials as well. The equation becomes p of x is equal to g of x into q of x plus r of x. As mentioned earlier, this entire topic can be covered using 3 basic concepts, namely remainder theorem, factor theorem, and the long division method. We will start with the first two. So what is remainder theorem? Let me just state the formal definition. Okay, let p of x be a polynomial of degree 1 or more, and let a be any real number. If p of x is divided by x minus a, then the remainder is p of a. Factor theorem states that let p of x be a polynomial of degree 1 or more, and let a be any real number. If p of a is equal to 0, then x minus a is a factor of p of x. Or second point is, if x minus a is a factor of p of x, then p of a is equal to 0. Both are converse of each other. Okay, there is a simple intuition behind it. There are multiple terms used here that confuses the students. I'll explain each of them one by one just to be clear. If we write any name like p of x, it means we are talking about some mathematical expression which is expressed in terms of x. For example, x square plus 2x plus 1 or x minus 1, etc. But if I put p of a and say that a is some constant, it simply means that I am assuming some value for p of x. Since x is a variable, it can take different values. At different values of x, this expression p of x assumes different values. For example, if we are in our example, we have taken the number of guests as x minus 2, right? The number of glasses that mother prepares for. Okay, so let us assume that your father brought in 6 guests. Then how much your mother will prepare? How many glasses will your mother prepare? It will be 6 minus 2. In this case, we are finding out nothing but p of 6. There is another concept which is 0 of a polynomial. This is the constant value which x can take where the entire expression becomes 0. So in other words, it is simply the solution if we take it as an equation. If we take x minus a is equal to 0, this is the equation, right? So a value a at which the equation becomes 0 is the 0 of the polynomial, or simply the solution of the equation. Remainder theorem says that if p of x is divided by x minus a, then the remainder is p of a. Why? So a is the solution or 0 of x minus a, right? So when we put x is equal to a, then x minus a becomes 0. According to division algorithm, p of x is equal to g of x into q of x plus r of x, right? If we put the value of x is equal to a, then in this case g of x into q of x, this product becomes 0, and what we are left with is r of x. But in this case we have assumed the value of x is a, and hence we get that p of a is equal to r of a. In simple words, if we assume the value of x to be the 0 of the divisor, then we simply get the value that is equal to the remainder in the same case. Okay, factor theorem just takes it one step further. How? Simply, if you just have to recall the concept that if one number is a factor of some other number, then it is going to leave the remainder 0, right? So it's if you simply assume that x minus a is a factor of p of x, then in this case r of x is going to be 0. So in the case of remainder theorem, if you put p of a is equal to if you put x is equal to a, then in this case p of a will become 0, because r of a is going to be 0. G of a completely divides p of a. If we consider our own example, we get the equation as x cube minus 8 is equal to x minus 2 into q of x plus r of x. Okay, since our divisor is x minus 2, 0 of this expression is 2, right? So if we put x is equal to 2, we get that LHS becomes 0, and thus RHS becomes r of 2. R of 2 is nothing but 0. So this says that states that by factor theorem, this x minus 2 is a factor of x cube minus 8. In order, we can simply get quotient of x using the long division method. Long division method is a lengthy procedure. These remainder theorem and factor theorem gives some insight into the situation early on. Okay, to derive enough things from these two theorems, you don't have to proceed to long division method, right? Long division method is exactly similar to the normal division method when you are using two numbers in order to carry out the division. When you are starting out, I will suggest that while writing the dividend, write out all the powers of x cube plus 0x square plus 0x minus 8. This helps you think in the manner that these powers exist. They just their coefficient is just 0. Okay, arrange the terms in descending order of their powers. Like the division method, we are going to focus on eliminating the biggest power we have in our hand. So here, first of all, we have the term x cube, 3. We need the power of 3. But what is our divisor? X minus 2. What is the highest power available here? 1. Right? So we multiply x minus 2 with x square. So we get x cube minus 2x square. Write it exactly under the first two terms. Okay. Now subtract it. As you can see that x cube minus x cube gets to 0. We are left with 2x square. Bring down the next power, which is 0 into x. What is the highest power we have now? It is 2 into x square. So we need x power 2 and the coefficient needs to be 2. You can see that we are getting 0 as a remainder. This means that there is this x minus 2 is a factor of x cube minus 8. Just for practice, let us take another example. I would like you to pause for a second and try it out yourself. Let's proceed with the long division. So we have 3x plus 2. Highest power is x cube. We need some multiple which is of power x cube. We need to multiply the divisor with something which has power of. So write down what is p of x, write down what is g of x, write down what is q of x, and then write down what is r of x. R of x is plus 1. Q of x is 4x square minus 7x plus 3, that is quotient. And g of x is divisor, which is 3x plus 2. And p of x is our dividend, which is the bigger equation, which is 12x cube minus 13x square minus 5x plus 7. Alright guys, so I hope this covers up any doubt that might occur. So yeah, see you next time. Do mention any doubt if you have.